Hello, welcome to the second episode of I'm Not a Math Person. Today I want to go over the topic of addition specifically with natural numbers and one type of integer. The type of integer we will use is 0. We won't use any of the negative numbers from the realm of all integers because I want to keep it simple so we can just focus on the idea of addition. We will introduce new vocabulary as well, such as the sum of numbers, composing numbers, and decomposing numbers. And I want to show how they're all connected together and why they're all connected together, or how they're all connected together. I'll also introduce, I'll try to make it less abstract because I know that sometimes mathematics can seem very abstract, where we're not sure how to make sense of it because it seems like it's only an idea. But if we add something solid to it, like a chair or a tree, 7 chairs, 3 trees, then it becomes a little bit more clear. So with that, let's get started. Okay, so first, what I want to do is do a quick review from the first episode. If we remember, we used this symbol to represent all natural numbers. And if you remember, all natural numbers were the numbers 1, 2, 3, 4, 5, and all the way to 10, and all the way to 100, and all the way to infinity, meaning that's a terrible infinity. I'll do it this way. So then 1, 2, 3, 4, 5, all the way to 10, all the way to 100, and it just keeps going and going and going. So those are all our natural numbers. And if we remember, we placed all of our natural numbers in this little box. So I'm going to place this box down here. Then the next thing we had was we had all integers that kind of had this Z looking symbol, and the Z this all integer Z looking symbol represented all your numbers from 0 to 1, 2, 3, 4, and all the way to 10, and all the way to 100, and all the way to infinity. Then on the other end of this, we had our negative numbers, -1, -2, and all the way to negative infinity. And to represent this, we also put this in a, we also put this in another box where all of our integers were, this is a terrible looking box, but we had all our natural numbers and all our integers, meaning all natural numbers are integers, but not all integers are in natural numbers. And you can see that from up here and here. All our natural numbers here included in our integers here from 1 all the way to infinity. But for natural numbers, we don't have any of our negative numbers. Those are only included in our integers here. Okay, so for addition, what I want to do is what we are going to use are all natural numbers. Now, I'm not going to go into the higher up numbers like 1,000, even 100, 200, 300, or 20s even. I'm just going to stick with the basic numbers between 1 and 10, just so we can get the idea of addition. So we'll be using 1, 2, 3, 4. Not all of these, but some of these. And for the integers, the only number I'm going to use for integers, the only integer I'm going to use is 0. Even though we have all these other numbers here ranging all the way to infinity, and we have all these negative numbers to negative infinity, I'm only going to use 0. And you'll get the idea why in a moment. But so to introduce addition and the sum of numbers, what I want to do is first I want to draw this box here. Now this box is going to be a representation of rooms, or a room, and we want to fill it with chairs. But here's the thing. I am a terrible artist. I cannot draw a chair to save my life. I can't draw anything. I could barely draw a square to save my life. Clearly, I'm not an artist. So what we will do instead is we'll write out chair, but we also don't want to write the word chair down all the time because it's going to become tedious. So what I want to do is I'm going to write this X, and I'm going to define this X. X is defined as a chair. Now I'm using this symbol right here, which means defined, but I'm loosely using it. Later on in higher up maths, you will use this often to define something. And it becomes more complicated when you use it, but for right now, just for this, I want you to be familiar with this sign. And it's okay if you've never seen it before. I just want you to see it now, so later on it doesn't become a shock to you when you do see it. You'll recognize it and you'll say, oh, I know what that sign means. It means define. So for right now, loosely using it, X is defined as a chair. So right now we have nothing in here, nothing in this room. So the representation of nothing, 0, we'll say 0 chairs, or 0 chairs. And that's the only time I'm writing this right now, because like I said, it's going to become tedious if I just keep writing chairs every time. So we'll have 0 chairs in here, but I want to put one more chair in there. I want to add a chair in there. So we're going to add 1 chair. So we can say there were 0 chairs, but now we added 1 chair. So what is that equal to? Well, 0 and 1 is just 1 chair. Okay, so now we know we had 1 chair in here, but we want to add another chair, maybe 2 chairs, maybe 3 chairs. Let's go with 4 chairs. So we added 1 and 1 and 1 and 1 here. So now before, we know we had 1 chair, but we added 1, 2, 3, 4 chairs. So I can do this a couple of ways. I can use the symbol for chairs equal to some number, or I can write down we had 1 chair, then we added 1 chair, then we added another chair, then we added another chair, and then finally we added 1 more chair. Now the long way of doing this is by counting all of these ones, which is 1, 2, 3, 4, 5 chairs. Now we have 5 chairs. Or we can write the quick way using the symbol 4 to represent 4 individual pieces. 4, 1, 4, 5. So we can look at this 2-way and say this 2 ways. 4 added to 1 or 1 added to 4 equal to 5. The sum of 4 and 1 is 5. Or we can say the sum of 1, 1, 1, 1, 1 is equal to 5. Or we can say 1 added to 1, added to another 1, added to another 1, added to another 1 is 5. Or 1 plus 1 plus 1 plus 1 plus 1, 5. And you can see quickly how tedious this is to write all these individual ones out. It takes time, and it takes a lot to say. So the quickest way to do it is by just writing the symbol down 4. And by writing associating these numbers with something solid like a chair. And it doesn't have to be a chair. It could be anything you want it to be. It could be apples. It could be a horse. It could be a house. It could be trees. It could be anything you want it to be. The thing is, the best way to do this is to find something solid that you can place these numbers with, as we see numbers everywhere all the time. Associate these things with numbers will help you see it and make sense of it. Okay, so now what I want to do is I still want to keep the idea of X is defined as chairs, but I'm not going to draw the diagram or the box where we want to fill the room with chairs. Instead, I just want to stick with the numbers and associate the numbers with chairs, a solid object, something that we can make sense of. So the numbers on their own are not something just abstract. We can see chairs, or it could have been anything else also. It could have been apples, it could have been a dog, it could have been cars, it could have been houses, it could have been trees, it could have been anything. We're sticking with chairs, so everyone knows what a chair looks like, and we can visualize these numbers associated with them. So now what I want to do is I want to write down 7 chairs plus, let's say, 3 chairs. And then also another way we can write this, or write numbers down in an order, let's say we have 6 chairs added to, let's say, 2 chairs. So what we can do here is we can visualize this 1 by 1 by 1 by 1 by 1 chairs, or we can just go simply off the symbol, the representation of 7 individual chairs or 3 individual chairs. And if we add these two together, we know 7, 8, 9, 10. That's 10 chairs. 6, 7, 8 chairs. Now I want you to take notice of something here also. So we will introduce the vocabulary of composing and decomposing. We can say is 10 decomposed is 3 and 7. 8 decomposed is 2 and 6. Now, there are many ways you can decompose a number. This isn't always going to be the case to decompose 10. What we can also do is write down something like, let's say, 10 chairs decomposed to 5, and 5 chairs. Well, can we decompose this any further? Yes, we can. 3, 2 chairs. 3, 2 chairs. Add little pluses there just to keep track. But that's not the only way. I mean, clearly we have 7 and 3. That's another way to decompose it. This is another way to decompose it. This is another way to decompose it. Or you can just take 9 chairs plus 1 chair. That's 10 decomposed, 9 and 1. If we compose 9 and 1, we get 10. If we compose 3, 2, 3, 2, we get 10. 5 and 5, 10 composed. The same thing is over here with our 6 and 2 and 8. We can decompose 8 in many ways also. We can do 4 and 4, 2, 2, 2, and 2. But when it comes to numbers like these smaller numbers, there is a finite way where you can decompose numbers, but the larger the number gets, the more complex composing and decomposing gets. But what I'm just trying to do is just get the basic ideas of adding numbers and composing or finding the sum of numbers. These are all connected that way. The sum of 7 and 3 is 10. The sum of 6 and 2 is 8. 6 and 2 composed is 8. 8 decomposed, 2 and 6, or 4 and 4, or 2, 2, 2, 2. And likewise with 7 and 3 and 10. Okay, so what we did today was we briefly went over composing, decomposing. We went over the sum of numbers, addition, adding numbers, and we showed how they're all connected together. We went over the symbol, we used the symbol plus, we used the equal sign symbol, and we used define. I wouldn't worry too much about this one because, again, later on you will use it more often, but that's in the higher up maths. For right now, I just wanted to introduce it to you so it's something that when it does come up again later on, it won't be completely weird and out of this world when you see it. So don't worry too much about it. Now, what I would like for you to do is to, on your own, compose numbers and decompose those numbers. Find the sum of numbers, add numbers together, and then once you add these numbers together and get your final answer when they're combined together, then try to decompose that number into different numbers. For example, if we have 5 plus 3, that's going to equal 8. Well, we know 8 decomposed is 5 and 3. What else can we decompose 8 with? We can get the numbers 4 and 4. 4 plus 4 is 8. The sum of 4 and 4 is 8. 4 and 4 composed is 8. But what's another way? Okay, well then maybe, let's say 6 and 2. 6, 7, 8. 6, the sum of 6 and 2 is 8. 6 added to 2 is 8. If we compose 6 and 2, we get 8. If we decompose 8, we get 6 and 2. Now there are many more ways you can do this. 2 and 2, 2 and 2, or 1 and 1, and 3 and 3, or 4 and 2. But try to do that. Write down 15 plus 13. What does that equal to? And then again, find that number, the total number you get, decompose that, and try to come up with other numbers that when you combine them together, you'll get that same answer. Okay, so that's it for episode 2 of I'm Not a Math Person on the subject of addition with natural numbers. I hope this helped bring a little bit more insight for you on the subject of addition with natural numbers. If there's anything that you didn't quite understand, or if I didn't explain it in a way that gave some understanding for you, please direct message me or leave a comment, and I can maybe do a follow-up video later on and explain this process in a different way. Later on, we will dive more into all integers and rational numbers, irrational numbers, and all real numbers. But for now, we're going to stick with natural numbers because I think it's easier. The next video I do will be on the subject of subtraction, but since we've gone over composing and decomposing numbers, that'll make subtraction a little bit easier to understand. So until then, I would say practice. There's no substitute for practice. What I would like you to do is, like the last example I gave, is take a series of numbers anywhere between 1 and 100, 1 and a million. Take any of these numbers and combine them all together. Find the composition of these numbers. What are these numbers composed? And then take that total and decompose it and find out what other variation of numbers we can make up that total again. So until the next episode, I hope this video help alleviate some of that math anxiety. And I hope that, in fact, after going through this, it brought some understanding for you, and it helped you feel like, in fact, maybe you are a math person.